All right, this is a problem from your finals review PowerPoint. We're just dealing in one dimension here, so this is a one-dimensional kinematics problem. You've got your equations down here. You might not be able to see them on this video, but you have them in your PowerPoint. So Cameron's dad's Ferrari, from Ferris Bueller, accelerates from its resting point at a rate of 65 meters per second squared. Immediately I know I have an acceleration. Acceleration equals 65 meters per second squared. Toward the window, 8 meters away. Okay, so I'm dealing with a distance of 8 meters. All right, those are explicitly given to me. How long, so I see those words, I know I'm looking for a time, all right, before it smashes through the window and meets its untimely demise. Okay, so we only have two variables here. Generally, I'm going to need 3 variables at least to solve one of these equations. So let's look for anything implied by this. Accelerates from its resting point. Keywords there, resting point. If something accelerates from a resting point, I know it has an initial velocity of 0. All right? So now I have my 3 variables. Distance, acceleration, initial velocity. Looking for time. So I know I can immediately go down to this equation. Now, for those of you who can't see it, I'll go ahead and write it up here. Distance equals initial velocity multiplied by time plus 1/2 times the acceleration times time squared. All right, so now I can plug in those variables. 65 meters per second squared is my acceleration. My distance is 8 meters. Let's go ahead and plug that 8 meters in over here. Initial velocity of 0, that eliminates this whole chunk of the equation. I'm left with 1/2 AT squared, so 1/2 times acceleration, 65 meters per second squared, times time squared. 1/2 times 65 gives me 32.5 meters per second squared times t squared equals 8 meters. And then you can go through the algebra from here, divide by 32.5, take the square root of both sides, you should get your new time. All right, being the kind person I am, I went through and calculated that out for you. Notice you divided this side by 32.5, you ended up with 0.246 seconds squared. Your meters cancel out, leaving in seconds squared. So square root of each side, you get 0.5 seconds as your time, which is a reasonable amount of time you'd expect for a car to go 8 meters at a huge acceleration of 65 meters per second squared.